Hello guys, welcome you all for this end-to-end session on AIML where you guys gonna learn everything that you guys need in order to become a successful data scientist. Hope you guys are enjoying. We are enjoying and we are learning a lot. Each and every day we are just improving our knowledge and we are just learning a new things. Hope the same thing for you guys. So today is a session on unsupervised learning. Guys, actually we have completed a part of machine learning, supervised learning. Okay, we have gone through the types of supervised learning like regression, classification, different models inside it, how to evaluate it. We have completed a part of machine learning. We are moving into the other part, that is unsupervised learning. So yeah, that's the thing that we're gonna see today, like the concept, the theory concept of what is unsupervised learning. That is what we're gonna say. What are the things that we are having in unsupervised learning? So before coming to the session, guys, make sure, as I always say, make sure you guys watch all the previous session videos so that you can have a better understanding and better clarity of what we are saying today. Okay, so without wasting any time, let us jump into today's session. As I mentioned, we have completed supervised learning. It is one of the technique which is under machine learning. Now we are going for unsupervised learning. So before going for this, what is supervised learning? We have a mission. We are having an apple and mango, like apple and banana. We give a mission. Yeah, this is an apple. It is in a circle shape and red color. Learn it. And we are having a banana. It is not in a circle shape and it is in yellow color. Learn it is as a banana. We will give the label for the object and we will train our model. That is called as supervised learning. Unsupervised learning. Let's see what it is. Unsupervised learning is a machine learning approach that allows computer to discover patterns and insight from a unlabeled data without explicit guidance or supervision. Okay. We will just give apple to the machine. Machine itself get the apple. Okay, it is in a circle shape and it is red color. Okay, I will just have it in a category A. Yeah. I will give a banana to a mission without saying it's a banana. Okay, it is not in a circle shape and it is in yellow color. I will put it in category B. It doesn't know whether it is apple or banana. It know category A, category B based on the feature. If I give a new thing as an apple, okay, it is in a circle shape and red color. Okay, I will throw it to the category A. That's it. Okay, this is what called as unsupervised learning. Here the model doesn't know the label, but based on the feature, it itself learns without explicitly programmed. That is what called as unsupervised learning. Hope you guys can able to understand. This is what I will say. It's a simple explanation that you guys need to know. And moreover, guys, I will say most of the interviews they're gonna ask these questions only. What is unsupervised learning? What is supervised learning? How they differs? Overfitting, underfitting. These kind of questions will be asked. So make sure you guys can understand. If you guys doesn't understand, just ping in the comment section. We will take up and we will solve your doubt. We are here to do that. Okay. Hope you guys can able to understand. Yes, sir. Over to you.
Okay, uh, guys, let's understand this unsupervised learning. Okay, unsupervised means wherein the data is not labeled. That's what let me simplify it. Very basic simplification. So in supervised, data is labeled and output is already defined. Okay, but here unsupervised learning data is not labeled. Data, this machine learning has to learn itself, but that doesn't mean you don't have to do pre-processing, write data, write characters, write model, uh, EDA, all those things you have to do on data. Okay, it doesn't mean that you can put anything in, I'll say unsupervised will learn from unlabeled data. It's not that unlabeled data. It is it is clean data, but yes, it is not labeled in terms of like it is not that much simplified, classified and labeled, but it is clean. It is as per the objective function, as per the problem statement, as EDA, pre-processing, everything is done. Okay, so understand this. So, so unsupervised learning is a machine learning approach which allows computer to discover patterns, insights from unlabeled data. Unlabeled data, or you can say unseen data, unseen patterns it has to discover, right? Which is not discovered by human beings. It has to, without explicitly guidance or supervision. That is why unsupervised. There is no supervision and no guidance. Eh, So you have to train it. Orange is like this, apple is like this, and it has to learn accordingly. It has to learn from the data accordingly. Okay, and it will go and unsupervised, it can do wonders. If your data is cleaned, you have chosen the right model, it can do wonders. You will be surprised to see the insights from the data that you never have expected. Like, there's a case study, guys. uh, in US or Western countries, if you go to big Walmart or big supermarkets, they will keep diaper and beer. Diaper and beer nearby, they will keep always near. So whenever people, like, they have found this, data scientists or all researchers, they have found this, that's called market basket analysis, right? There's an algorithm also. So people will go, people who buy diapers, they also buy beer. So they found this kind of thing. And you will see, because usually in normal logics and normal research, you will not find such patterns. And that is what makes machine learning, AI, ML, data science magical, guys. It will give you such insights you never ever even would have imagined in your dreams. So that is the power of machine learning, deep learning. So keep learning deeply.
Yeah, let's move on. Okay. What is unsupervised learning? Let's somewhat extend the concept. Okay, unsupervised learning aims to identify underlying structures and relationships within data, allowing computer to learn from unlabeled information. As myself and sir is explaining, we have unlabeled data and it's gonna learn by itself, and in order to classify clusters. Okay, let's see what are the types of unsupervised learning we are having. Clustering, grouping similar data points into cluster, revealing distinct subgroups within a data. As I mentioning, right, we are having something called as an apple, which is a category A, and then banana category B. The model doesn't know it's an apple or a banana. It know category A, category B, based on the features. It just gonna cluster the things, group the things. Okay, that is what clustering. Dimensionality reduction, reduce the number of variables in the dataset while preserving its important feature. Okay, I will say one thing. Same example. Let's see. Okay, let's look at a different example. Like we are having a something called as a house price prediction. Okay, where we're gonna have nearly like 10 plus features in order to predict the price of the house, like the ground, the where the house is located, what is the square feet of the house, how many bedrooms are there, how many bathrooms are there, how much kilometer from the house to hospital, like that. It will be having nearly 10 plus features. From the 10 features, this dimensional reduction will took only 2 to 3 features, which is very important for us to predict the target, that is the price of the house. Okay, so from 10 features we are reduced to 2 features or 3 features. What happens means now we are reducing the dataset size so that we are able to train our dataset in a more faster manner, and it is more effective also. Okay, and the same thing, we are not reducing any information, we are just using only important information. Okay, other things we are just leaving out, those are called as unimportant informations. Okay, so that's what this dimensional reduction, I will say in a simple term, high dimension to low dimension, 10 features to 2 to 3 features, that's it. Anomaly detection, let's see what it is. Identifying unusual or outlier data points that divert significantly from the norm. Okay, I will say it's more likely for transaction like data, right? So we are getting lots of anomaly in the share market, stock market, those things. Okay, so whenever there is a trend, there is some mismatch in trend, it will gonna create it as an anomaly. Okay, it's like a outlier. So whenever outlier is predicted, it's gonna treat it as a anomaly data. Okay. So I will say these are the three different types which are present in the unsupervised learning. That is unlabeled data. The machine learn unlabeled data by itself and categorize the things. And below which we are having like nearly like three categories. One is clustering, Groups the data based on the features, dimensional detection, high dimensional features to the low dimensional features, anomaly detection in a sequence of data or in a trend. If there is some outlier, that is called as anomaly detection. Hope you guys can able to understand. I have simplified everything. Okay. Yeah, sir. Over to you.
So, what is unsupervised learning, guys? So, unsupervised learning aims to identify underlying structures, relationship within the data, allowing computer to learn from unlabeled information. Okay. So, first is clustering. Clustering is a group similar like grouping similar data points into a cluster, revealing distinct subgroups within the data. That is one. Then we have dimensionality reduction, like reducing the number of variables in the data set while preserving the important information. So this is how we do dimensionality reduction. These are the elements of unsupervised learning. So anomaly detection is identifying unusual or outliers in the data point that deviates significantly from the normal. So normal distribution, whatever is nearby the spread normal distribution, okay, baseline, we consider that our, which are the extreme parts of the normal distribution very far from either sides, we consider them as anomalies or outliers. So that's what it will detect that. Okay, so unsupervised learning, they are like clustering, dimensionality reduction, anomaly detection. These are very important aspects of unsupervised learning. Okay, keep in your mind, keep learning, absorbing, digesting, and applying all the information with simplicity.
Yeah, as I was mentioning, like, yeah. So we need to think of this or the some of the categories that are present in this unsupervised learning. Hope you guys can understand, right? What now you guys able to understand what is unsupervised learning and what are the types that we are having. Okay, let's move on. Clustering. Let's go one by one. Clustering. So what is clustering? Clustering algorithm or unsupervised methods that group the data points based on similarity, creating clusters of the relevant related data. Okay, as I mentioning, right? So based on the features, if it is a circle or red color, it's gonna belong to a category A, that is apple, and the model doesn't know it is apple, it is category A. Whereas if it is not in a circle shape and it is in a yellow color, it's gonna throw it to the something called as banana. Model doesn't know it is banana, it is category B, like that. That is called as clustering algorithm. K-means, so guys, we gonna have a separate session for each and every algorithm, K-means, hierarchical clustering, and DB scan. Let's have a overview of it. Okay, separate session, tail session. We are gonna have a coding session. Let's see what it is. K-means clustering. Now have a general idea. K-means clustering, a popular algorithm that partitions the data into K clusters based on the distance to cluster centroid. I will put it in a simple manner. K-means clustering is a popular clustering technique where you're gonna separate the data based on the distance metrics. Distance. Next, hierarchical clustering. It creates a hierarchy tree-like structure by progressively merging or splitting clusters based on the similarity. Okay, here I will put it in a simple manner. There is a tree structure. You're gonna start from the single, two, three, four, like that. You need to keep on cluster in a tree-like manner. That is called as hierarchical clustering. DB scan, it's a density based clustering technique that identify clusters based on the density and connectivity of the data points. I will say simple manner. DB scan is like something like whenever the whenever you just project the data onto the matplotlib or using any visualization, whenever the density of data is very high, keep as a cluster. Here density high, keep as a cluster, like that. Based on the density, you just clustering the data. That is what called as a density based clustering. That is DB scan. Okay, now you guys can able to understand, right? We have seen three different kinds of clustering technique. That is K-means based on distance clustering, hierarchical based on a tree like kind of clustering, DB scan based on the density based clustering. Hope you guys can able to understand. I make everything simple. Okay, and one more thing, we're gonna have a separate session for each and every algorithm together with the theory, black box part, and then coding part. Okay, so yeah, now you guys just have a basic understanding of it. Yes, sir. Over to you.
Okay, So clustering algorithms are, guys, they are very powerful algorithms. Clustering algorithms are unsupervised learning algorithms. Okay. Uh, the method that they group data into like different point based on similarity, creating like they make the groups. Okay, that's what is clustering means. Clustering or groups are the same thing. They make different groups or clusters based on similarity and creating clusters for the related data. That's what they'll do. And K-means clustering is algorithm which is a popular algorithm that partitions data into K clusters, means different classes or groups you can understand, based on distance and cluster centroids. Okay, like which is the nearest point and centroid or near. Okay, so that this based on the centroid it will create clusters. Okay, ultimately if you see they're doing first principles, they're splitting, making small clusters and understanding that and solving the bigger problem. Okay, that's what, because there the performance will be better. So the if you see idea, that's the idea, splitting problem into small pieces, data into small clusters so that they understand well, and then there's a good prediction and performance. That's what is the main. Hierarchical clustering is the tree structure. So there is a hierarchy. If you see tree structures, okay, we have a hierarchy. So that's why there we use tree structures by progressively merging or splitting clusters based on similarity. Again, the same thing, based on hierarchy. The same thing, splitting into small clusters so that you can manage it well, and there would be a great performance and good output, because you can manage small groups, clusters, and then you solve the bigger problem. That's what, again, the hierarchy is there because we are using different model which is tree structure. Then dbs scan is density based clustering that identifies clusters based on density. So there's a density. Again, making clusters based on density, connectivity of the data points. What is the density? Is there more density? One cluster, lesser density, another cluster, the random density, another other different forms of density clusters, so that we understand data well and find the patterns and give the insights. That's it. Let's move to the other section.
Sure, sir. Yeah. Yeah, moving on, we're gonna have a next thing. Okay, now you guys can able to understand clustering, right? We are moving to the next category, dimensionality reduction techniques. So let's see what is dimension. We already discussed, right? Higher dimension to lower dimension. That's it. Dimensional reduction techniques aims to simplify data by reducing the number of variables while preserving the essential information, making data easier to analyze and visualize. Okay, so consider we are having like a 10-dimensional data. Okay, we are having nearly like a 10 dimension. Okay, and we are just reducing it to 2 to 3 dimension. What happens here means we are reducing a dimension such a way that it doesn't remove the important information also. That is what it makes the data easier for visualization and analysis. So I will say in a simple manner, higher dimension to lower dimension conversion from 10 different features to only 2 to 3 different features, which has the very important features and which will represent the all the 10 features that present in the data by using the 3 features. That's it. Let's see, we are having different dimensionality direction technique. Let's see. Okay, principal component analysis, I will say PCA. It's a simple technique and more widely used dimensional direction technique. A linear transformation that defines a principal component which capture the most variance in the data. In PCA, we will be having a line and we will project different dimensions into only those lines. So line is a 2-dimension, right? We will try to adapt multiple dimension, that is 10 dimension, 5 dimension, anything to only 2 dimension. That is called as PCA. Then we are having t-SNE, that is T distributed stochastic neighbor embedding. So it's a non-linear technique used to reduce the higher dimensional data to lower dimensional data while preserving the local neighbor structures. PCA, t-SNE, what's the difference? PCA is for linear transformation, that is linear data. Using a 2-dimensional line, it is able to convert the dimension from multi dimensions to the only two dimension. Whereas t-SNE, it's a non-linear, so it will create a circle or different kind of shapes in order to make a multi-dimensional data to a single dimension, that is high dimension to lower dimension. LDA, it's a technique that is a linear discriminant analysis. It's a technique that seeks to find an optimal linear projection of a data onto a lower dimension space while maximizing the class separability. Okay, I will say one thing. LDA tries to fit a line so that the classes becomes widely distributed. There is a wide range of distance, and I will say maximum distance between two different classes. That is what LDA. Now I'll put the things very simple. Dimensional reduction means I dimensional to dom dimension. For example, 10 features to only 2 to 3 features. And also that 2 to 3 features should represent that 10 features. PCA, it's a one of the technique for dimensional reduction where we will create a linear transformation, that is a line, in order to make multiple dimension to a single like a two dimension, that is a line. t-SNE, it's a non-linear thing where it creates a shape kind of thing like circle, any shape, circle, triangle, rectangle, in order to make a high dimensional data to low dimensional data. Whereas LDA, it is used to create something called as a line. It is also create a line like PCA, but like here it tries to make classes widely distributed. That is the distance between two classes which is separated. Like it should be very maximum. Okay, so that is what all about this dimensional detecting, and then the features that like types we are having. Guys, again these three things that we are seeing, like t-SNE, and then PCA and LDA. We're gonna have a separate session for each and everything, and then together with the black box, what it is happening, theory behind it, and also the coding session. Okay, now you guys just understand what it is. Okay, hope you guys can able to understand. If it doesn't understand, please make sure you put it in the comment, and we will take up and we will solve it. Yeah. So yeah, sir, over to you.
Yes, so dimensionality reduction technique DRT. So it is used simply to simplify the data by reducing the number of variables. That's what it will again do, simplify the data, reducing number of variables while preserving the essential information. You need to have the, because guys, see, if essential information is removed, then you are not going to build a great model, okay? And performance will be very, so that is why. So you have to reduce the um, simplify data, reducing number of variables, but keep the essential information there and making data easier to analyze and visualize. That's what it is. So keeping the important information which is relevant as per the objective function you want to achieve. Okay. So PCA is a technique used for DRT. Okay. To learn transformation. So it is a linear transformation that finds the principal component. Okay. So okay, it's a linear transformation that finds the principal component which is captures the most variance in the data. See, PCA, the fundamental, if you understand, the fundamental idea of PCA is to capture the most variance. Lesser variance works, but there shouldn't be most variance in the data. And that is what it is going to transform. Okay, it will do transformation to find the captures the most variance in the data. That's what you need to understand about PCA. Okay, and then t distributed stochastic neighbor embedded t-SNE, let's call it t-SNE. Okay, so t-SNE, it's again a non-linear technique used to reduce high dimensional data to lower dimensional while preserving local neighborhood structure. Again, see, if you understand DRT, we understood that we have to preserve the right information, essential information, and rest we have to remove, reduce, simplify. Okay. So these techniques somehow will behave similar according to the definition of DRT. Okay. So in PCA, what happens? It will capture the most variance in the data. In t-SNE, it is going to It's a technique which reduces high dimensional data to lower dimension while preserving the local neighborhood structure. Okay, because will that is an essential part in the model, right? Then we have LDA. It's a technique that seeks to find optimal linear projection of data into a lower dimension space, okay, while maximizing class separability. So all these three techniques like have their own characteristics, and there is a very thin line, okay, and they in PCA it is going to capture the most variance in the data while preserving the integrity, other aspects of essential data. And then we have t-SNE. Again, it's a non-linear technique we used to reduce the higher dimension to a lower dimension, preserving the local neighborhood structure. Then LDA, it is going to seek and find the optimal linear projection of data into a lower dimensional space while maximizing the class separability. They need to keep the classes separable so that there is no confusion. If again classes become same, then there would be a confusion with the data sets and those classes. Then model will not learn properly. So that is why these techniques are super efficient and super powerful for dimensionality reduction techniques. They are very super because they are going to make your model optimally perform. Like their model will have a high performance when you use these techniques because you will have billions of data set, millions of data set. You don't need all for your performance to build a great model, like, right? Okay, so you need right essential information to build a great model. Okay, that's what is the main, and these techniques are going to help us. They are unique in their characteristics. So keep learning deeply and understand all these terminologies, absorb the information, digest the information, and apply all these concepts. Keep learning deeply.
Yeah. So, guys, yeah, we will pause here. So, we have introduced you to a new topic called as unsupervised learning. We have seen about different types which are present in unsupervised learning, and we have discussed elaborately about the clustering technique and then dimensional reduction technique. So, we will pause here, guys, and we will all meet in the next session where we will be extending this unsupervised learning concept of overview of unsupervised learning concept. Hope you guys have enjoyed today's session. If you guys have any doubts, just make sure that you guys just ping in the comments. So we will take up and we will solve your doubts. Okay. Yeah. Until next session, guys. Take care and learn everything. Okay. Keep learning. So that's the only thing that you can that makes you feel expert. I will say. Okay. Just keep learning, guys. That's the only thing. Okay. So yeah, guys. Until next session. Take care. Bye, guys. We all meet in the next session. Bye, guys. Take care.
Take care, guys. Keep learning, absorb the information, digest the information, apply the information, and subscribe to our channels. Also, press the bell icon so that you will get notification for all the sessions and give us feedback. Build your long-term objective function for your career and keep learning deeply with persistency, consistency, perseverance, and patience. And that will give you satisfaction and you will achieve great heights in the career and you will become world's best data scientist, AI ML engineer, AI researcher if you have these qualities. First, build the architect for learning: patience, consistency, persistency, long-term objective function, long-term vision for learning. Then everything will come. Okay? Keep learning deeply. Thanks.